Bismillahirrahmanirrahim. In today's lecture, we will define a field. A field F is a set with two operations, that is addition and multiplication. Satisfy the following properties. Number one is closure property. That is for all A, B belong to F. Uh, A plus B belong to F. That is F is closed under addition, and also A dot B belong to F mean F is closed under multiplication. So the set F is closed under both operation, that is addition and multiplication. And the number second property is associative property. For all A, B, C belong to F, associative law holds under addition, and also associative law hold under multiplication. So third property is commutative property. That is for all A, B belong to F, commutative law hold under addition, and also commutative law hold under multiplication. That is A plus B is equal to B plus A, and A dot B is equal to B dot A. Number four is existence of identity element. That is the identity element with respect to addition and multiplications are also belong to the set F. So there exist elements 0 and 1 belong to F. Here 0 is an additive identity and 1 is multiplicative identity. So 0 and 1 both identities belong to F, such that for all A belong to F, each element of F, A plus 0 is equal to A. That mean additive identity belong to F, and also A dot 1 is equal to A mean multiplicative identity also belong to F. Now, fifth property is existence of additive inverse, which is for every A belong to F, there exists an element minus A belong to F. So for every A, there exists minus A, which is called additive inverse, such that A plus minus A is equal to 0. Mean if we operate A with minus A, that is additive inverse we get the additive identity. And number six property is multiplicative inverse. So for every element of F except 0, there exists a inverse belong to F. That means every element of F has multiplicative inverse except 0, because multiplicative inverse of 0 does not exist, such that A into A inverse is equal to 1. And the last property is distributive property. So for all A, B, C belong to F, we know that the distributive property hold. So if all these 7 properties hold, we say that the F with the with the two operation multiplication and addition is field. So in other word, we can also define field the set F with two operation and addition and multiplication is field if F with respect to addition is abelian group. So we see that the closure property with addition hold in F, associative property with respect to addition also hold, commutative property with respect to addition hold, identity element with respect to addition belong to F, and also additive inverse belong to F. As these 5 properties are hold with respect to addition, so we can say that F is abelian group under addition. And the second is F minus 0 with respect to multiplication is abelian group. So we also see that F is closed under multiplication. Associative law also hold under multiplication. Commutative properties hold under multiplication. Multiplicative identity belong to F. But in case of multiplicative inverse, we see that each element of F has multiplicative inverse except 0. So if as multiplicative inverse of 0 does not belong to F, so F is not group with respect to multiplication. So because 0 has no multiplicative inverse. So if we remove 0 from F, then each five properties also hold in F. So we can see that we can say that F minus 0 under multiplication is an abelian group. And the third one is which is distinct property where distributive law holds. So field can also be defined in this three axiom such that if F with respect to addition is a abelian group, and F minus 0 with respect to multiplication is the abelian group, and distributive law hold, then we say that F with combined with two operation addition and multiplication is a field. So now we will see some examples of field. Uh, Example number one, Z is not a field. That is the set of integer is not a field. So if we satisfy the axiom above axiom on the set of integer, we can see that Z is closed under addition, associative law hold and with respect to addition, and also multiplication, closes under addition and multiplication. Number third one is commutative law also hold with respect to addition as well as with respect to multiplication. Number four, additive identity and multiplicative identity belong to Z. Number fifth one is existence of identity element, which is also exist as 0 belong to Z, but inverse does not exist with respect to multiplication. That is, there is no integer except one which has a multiplicative inverse, because 2 has multiplicative inverse 1 over 2, which is not in Z. 3 has multiplicative inverse 1 over 3, which does not belong to Z. So as we see that multiplicative inverse of element of Z does not exist in Z, so Z is not a field. And the other examples are set of rational number and set of real numbers and set of complex numbers are fields. So this question is for you. You can check that the set Zn, that is set of integers under modulus n, where n belong to n is a field or not. So आपने ये चेक करना है कि जो Zn है कि क्या ये फील्ड है या नहीं है. If Zn is not a field, then also you can find for what value of n Zn is a field. So thank you.